And we're back to live in 1, 2, 3. Hello, my dear students. I hope you're all doing well. My name is Benatang Paton, and I welcome you to the channel Classroom, where we learn together. So today, my dear students, I have a very important topic for you all. It's about solenoid. So today we'll be learning about solenoid. What is a solenoid, and why do we study a solenoid, and why is a solenoid so very important? Okay. So I have already written the topic. The topic for today will be magnetic field due to a solenoid. So what did we learn in the previous video? In the previous video, we have studied about the magnetic field in a straight current conductor, which is circular. Then immediately after that, we studied the magnetic field in a circular loop. Okay, we have studied this. So if the wire is circular, then the magnetic field lines are straight. So we have learned about this too. Okay, at the side, at the corner, we can say they are like this. Okay, it goes straight, and finally it becomes, okay, it doesn't go straight, it goes straight at the center, but the circles become bigger and bigger. Okay, so it doesn't go straight, it gets, the circles get bigger, and finally in the center it becomes straight. Okay, so the magnetic field in a circular loop is straight, whereas the magnetic field in a straight current carrying wire is what? It is circular. Okay, so this is very important. So I assume that you know this. So in today's class, the knowledge of the circular loop is going to be tremendously important. So I want you all, if you are watching this video before watching the previous video, I will recommend you to go back and watch the previous video so that you will understand solenoid in one go. Okay, so it is highly recommended, and I sincerely request that you watch the video on a circular current carrying loop. Okay, so assuming that you have watched it and you have learned it, let's start our topic. So those who are tuning in regularly, you know that you have to grab a notebook, a pen or a pencil, and write down the notes. Okay, in case there are new students who are tuning in, I welcome you all. And then how we learn here is we always grab a pen or a notebook and then we write down. Okay, so please kindly do that. Okay, so in today's class, let's do a change. I'll draw the diagram here and then I'll be writing it here. Okay, so let's draw the diagram here. Okay, on my left, which is also your left, I guess, because you are watching like this, which is our left and our right. Okay, your right, my left, your left also. So today I'll be writing here, I'll be utilizing this part, and this part will keep it for drawing. Okay, so the first thing is let us define what a solenoid is. So define a solenoid. So what is a solenoid? Question: what is a solenoid? Very important. So what is a solenoid? A wire having large number of turns in which current is made to pass through is called a solenoid. Let me be very clear here, my dear students, that just a wire having large number of turns is not called a solenoid. Okay, a wire having large number of turns plus current is made to pass through, that is called a solenoid. So in the definition of solenoid, don't forget to mention in which current is made to pass through. Okay, remember that. So let's write the definition. A wire having a large number of turns in which current is made to pass, okay, is called a solenoid. So is called a solenoid, is called a solenoid. Now I have never admitted this in my online teaching, but then today let me admit that I don't have the best handwriting. Okay, so I've said this in my actual classroom in the school, but in the online classroom I have never said it. So today let me admit it that I don't have the best handwriting, but then I hope Okay, it's of course the handwriting matters, but it's understandable, I suppose. So do let me know, okay, whether you understand my handwriting or not, because I admit that I don't have the best handwriting, but I believe so at the same time that it's readable and it's you can make it out. So please bear with it. So a solenoid is a wire having large number of turns in which current is made to pass through. So it's just a wire having large number of turns in which current is made to pass through. So a wire having large number of turns in which current will be made to pass through. This is called a solenoid. Okay. Now, why do we study a solenoid? Very, very important. Why do we study a solenoid? So let's write this question. Why do we study a solenoid? So why do we study a solenoid? It's very important to know why we study a solenoid. We study a solenoid because when a solenoid is connected to a battery and current is made to pass through, okay, then the solenoid produces magnetic field similar to the magnetic field produced in a bar magnet. This is the reason why we study a solenoid. So let's write down why do we study a solenoid. So we study a solenoid because when a solenoid is connected to a battery and current, C-U-R-E-N-T, and current is made to pass through, it produces magnetic field similar to magnetic field produced in a bar magnet. Very important. So why do we study a solenoid? We study a solenoid because when a solenoid is connected to a battery, so if we connect a solenoid to a battery, plus minus plus minus plus minus, then current will pass through the solenoid, and when current passes through the solenoid produces magnetic field similar to the magnetic field produced in a bar magnet. And this, my dear students, is the reason why we study a solenoid. Now we will be studying in detail, okay, whatever we have written here, okay, especially this part, why do we study a solenoid, we will study each and every detail, okay. So now time to utilize this part of the area. So let me draw a solenoid here. So a solenoid is a wire having large number of turns. So let me draw a solenoid here. So a wire having large number of turns. 1, 2, 3, 4, 5, 6. This will do. So now let us indicate the direction of current passing through this wire. So let the current enter from this end. Let's say current I is entering. So the current will enter here all the way here. Then it will pass through this wire. It's a loop now. Okay, so the current will go down and then it will climb up again. So it will be here. Then again, it will drive here. Then this loop. Then it will go down. Then climb up. So go down. Take a turn. Climb up. So this, okay, these arrows indicate the direction of current in this solenoid. Okay, and finally it will exit from here. And then it will exit out. The same current which entered, the same current will exit out. So I hope till this much is easy. Okay, so far we have a wire, okay, which has got many turns, and then current is passed through this wire. Okay, current is passed through this wire. Now when current passes through this solenoid through this wire having large number of turns, then what will happen? It will produce magnetic field. Okay, but before that, now let us study some more. Okay, let us try to learn about the solenoid in detail again. So now, my dear students, I want you to focus on this part. So let us take one loop. Okay, so let's say we take this loop. So let us focus on this part. Let us take this one. I'll dissect this out. So if I take it out, then I'm taking out the loop, so it will be like this. Yes or no? Okay, so it will be like this. Now, so this wire is this one, then the current is flowing like this. So the direction of current, let me indicate here. This is the direction of current. So it goes in this direction, then it takes a turn up, and then it goes like this. Now, I want you to tell me the direction of current here. What is the direction of current here? Tell me the direction of current here. The direction of current is clockwise or anti-clockwise? This is, yes, this is clockwise. Okay, this is clockwise. Let's start from here. Okay, let's start from here. It is very important to know whether it's clockwise or anti-clockwise. In the last video, I have made it very clear to you. Always, okay, indicate your starting position. So let's start from here. Okay, if we start from here, then imagine this to be 12, then this is 3, then this is 6, and this is 9. So we are starting at 3. Okay, then where are we going? Follow the arrow. Then we are going to 6. From 6 we drive up to 9, then again it goes to 12. So 3 to 6, 6 to 9 to 12. This direction of movement is called clockwise. Remember, again and again, I'm telling you, always, okay, know where you're starting. Always know from where you're starting. The starting point is very important, okay, to know whether it's clockwise or anti-clockwise. Please remember that. So since we are starting from here, okay, since we are following this arrow, okay, we can start from here also. You can even start from here also. Then even if you start from here also, the drive will go down. So this direction will eventually give you clockwise. So in a loop, so this is a loop. This is a loop. Is it not? This is a loop. This is a loop. Okay, this is a loop. And then in a loop, if the direction of current is clockwise, so current direction is clockwise, then we have already studied in the previous video that the pole it represents is south pole. So this represents south pole. So that means these are south pole. All of these, okay, all of these are south pole. Now, I hope it's clear. How, if you're wondering how, then here, okay, all of these, okay, all of these are identical. It's not, this is this one, this is this one, this is this one, this is this one. All of these are the same only. We are studying one loop. The same thing will happen to the remaining loop. So this, by finding the pole of one loop, we can determine, okay, we can determine the pole of the other loops also. So the poles, okay, which you are, the loops which you see here, okay, these are all south poles. Okay, now to carry out this discussion further, okay, now let me show you. So I have something for you all, because this point is very crucial. Okay, so I hope you all understood that this is south pole. So just to clarify, okay, so a solenoid has large number of turns. So a solenoid has many loops of wire. So this is loop number 1, loop 2, loop 3, loop 4, loop 5. Here I have one loop. Okay, this is one of the many loops. Now, if I were to align, then it will be like this. Okay, it will be like this. Okay, if I have to show you the face, the flat face will be like this. Okay, so you are able to see the loop. Okay, for this, the solenoid has to be kept like this. The solenoid has to be kept like this. Okay, it has to be kept like this. If you are seeing the loop like this, that means the solenoid is facing like this. This is the starting, this is the ending. So it's like a caterpillar. Okay, it's like a caterpillar, more like this one. Okay, like this. So it could be like this, but if I show you this face, if I'm showing you this face, that means I'm aligning it like this and not like this. Okay, but we'll be studying like this. Okay, so if I have to show you like this, then I cannot show you like this. It has to be done like this. So remember, if you are seeing it, if I show you like this, that means the solenoid is also in this direction. Okay, the solenoid is placed it's like a missile coming towards you. But we will not study like this. I will have to keep it like this, because even the diagram is like this, parallel to the whiteboard, parallel to the whiteboard. So the diagram, okay, the solenoid is placed parallel to the whiteboard. Okay, so remember, we'll be studying like this. That means this face has to be oriented like this. This is the correct orientation to study. I hope you got it. Okay, so remember, we are studying it like this, in this direction, in this orientation. Okay, now, so now that it is clear, now, so this is one of the many loops. Now, so for once, let me show you like this, and then let's bring it here. So now you see here, okay, so current is going, the direction of current is clockwise. Now look at the arrow and tell me, look at the arrow and tell me, is this the direction of the arrow, is it pointing, okay, the direction of the arrows, are they clockwise or anti-clockwise? Follow the direction of the arrow and tell me, clockwise or anti-clockwise? This is clockwise. Okay, see here, 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. So 3 to 6 to 9 to 12 to 3 to 6 to 9 to 12. So this is clockwise, because this is the same loop. This is the same loop. This is this one, this is this one, this is this one, this is this one, this is this one. Okay, they're all same. Okay, they're all same, and this is the right orientation for me to look at it. Okay, so I'll be looking like this. All right, so now look at, now I'm on the left side. I'm on the left side. I'm looking at through the solenoid, and my eyes are here in the left side. So I'm looking here. Okay, I'm looking in this direction. So my eyes are on the left side, and I'm looking into the solenoid. So the face of the solenoid, okay, the face of the solenoid, the face of the loop which I'm seeing is this one, where the marking 1 and 2 is there. Okay, so when I'm looking like this, I'm looking at this face of the solenoid where the markings 1 and 2 are there. I hope it's clear. Okay, since the direction of current flowing in this loop, okay, in this loop is in clockwise direction, so I can conclude that this represents the south pole. So I'm seeing the south pole of the solenoid. I repeat, since the direction of current here is clockwise, okay, this loop represents south pole, so I'm seeing the south pole of the solenoid. Okay, but you know what, this loop has got two sides. Okay, one where the marking 1 and 2 is there, and the other where the marking is not there, the back side is there. So things are getting interesting now. So now this is my first position. Okay, this is my first position. Now let me change my position. The solenoid will still remain in this position. The solenoid does not change. It is me who will change my position. So I have changed my position. So now I'm at the other side. So I'm here now. Okay, I'm on the right side. Previously I was there. Now I'm here. Now I'm still looking into the solenoid. Okay, but now I am not seeing this part anymore. I'm not seeing this face of the loop anymore. Rather, I'm seeing the other side of the loop. Let me show you the other side of the loop. This part. Okay, I'm seeing this part. Previously I was looking at this part, okay, where markings 1 and 2 were there. Now I'm looking at this part. There are no markings here. So I'm actually looking at the back, at the back of the previous loop. Okay, at the back of the previous loop. Now interestingly, now let me show you and ask you the direction of current. Now look at this and tell me, look at the loop and tell me the direction of current here. The direction of current is clockwise or anti-clockwise? Look at the arrow. Okay, look at the arrow. You can still see the arrows, isn't it? So look at the arrow. Remember, if it was like when it was like this, it was clockwise. Now it's like this. So it'll be yes, it'll be anti-clockwise. But let's confirm it. Is it truly anti-clockwise? Let's see. Is it truly anti-clockwise? Let's see. So this arrow is going up and this arrow is coming down. Let's start from here. Okay, let's start from here. So this is 9, this is 6, this is 3, this is 12. So 9 to 6 to 3. 9 to 6 to 3 to 12. That's not normally how a clock moves. This is opposite. This is anti-clockwise. A clock moves 12 to 3 to 6 to 9. Here it's 9 to 6 to 3 to 12. 9 to 6 to 3. Look at the arrow. It's going down and it's driving up. This is anti-clockwise. If this is anti-clockwise, then it will represent the face of the loop which I'm seeing from this end when I stand here. Okay, when I look into the solenoid, the face of the loop that I'm seeing here represents which pole? Which pole? Yes, very good. It represents the north pole. So this represents the north pole. Okay, this is very crucial and very important. That's why I'm highlighting on this. So if I'm standing on this side, okay, and if I keep my eye here and I look, then remember, my dear students, that okay, from this end, from this side, if you stare into the solenoid, if you look into the core, if you look into the solenoid, you will be okay. The face of the loop facing you are all, you'll all give you north poles. Okay, and here you will see the south poles. I hope it's clear. Okay, so now you have, so now in a solenoid, okay, current is passing through, and then depending on the direction of current flow, you have got your poles, the north pole and the south pole. So if you have the north pole and the south pole, what will happen? Magnetic field lines will be generated. Yes or no? See, there it is. Okay, this is the reason why we're studying a solenoid, because when current passes through a solenoid, magnetic field lines will be generated. Now let's study, okay, the nature of the magnetic field lines generated in a solenoid. So now, since we have the south pole and the north pole, magnetic field lines will be generated. But how? How will the magnetic field lines be generated? You want to know, and I'll tell you. So the magnetic field lines will be generated like this. So it will be like this. 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 So the magnetic field lines, okay, the magnetic field lines generated will be similar to the magnetic field lines produced in a bar magnet. So let us also draw a bar magnet. So let's say this is the bar magnet. Then this is north pole, this is south pole. In a bar magnet, tell me, my dear students, magnetic field lines, they origin from which end? Yes, they origin from the north pole and they enter to the south pole. They origin from the north pole and they enter to the south pole. They origin from the north pole and they enter to the south pole. They don't coincide. Remember that they don't intersect, also they don't touch. And they go like this. So magnetic field lines, they emerge from the north pole and then they enter to the south pole. Emerge from the north pole and then they enter to the south pole. Remember this. Okay. So here also in a solenoid also, remember this, that the magnetic field lines will emerge from the north pole. Okay, so they'll emerge from here and then drive all the way and enter into the through the south pole. Remember this. So they'll emerge from the north pole. The magnetic field lines will emerge from this end of the wire, which is the north pole, and then they'll enter to the through the south pole. So here also they'll emerge from here, okay, and then they'll enter from here. So I hope it's clear. Okay, remember this. Okay, so this is how, okay, this is what happens when current flows through, when current passes through a solenoid. The solenoid generates magnetic field similar to the magnetic field produced in a bar magnet, and this is the reason why we study a solenoid. Okay, so one hack for you in the exam, remember students, okay, remember the point, okay, the loop from where current enters. So this point, this is the plus point, this is the positive terminal, and this is the negative terminal. These terminals, okay, we are getting from the battery. Remember, we have a battery too, na? So plus minus plus minus plus minus plus minus plus minus plus minus, like this. Okay, so one trick or one hack for you is to remember, okay, in exam, if you're confused, like which if you're given a solenoid and then you don't know, okay, which will be north, which will be south, like that, then one trick, remember the end from where current enters is considered as a south, okay, and the end from where the current exits is considered as the north. Simple. Okay, simple. And also, okay, and also remember, okay, anti-clockwise. Remember this trick, anti-clockwise. If current is flowing anti-clockwise, which means like this is anti-clockwise. So current is going anti-clockwise. Current is going anti-clockwise. Anti-clockwise. Anti-clockwise means north. Okay. Anti, N is there, na? Anti is there, is not? Anti anti, N is here. Okay, anti means north, so it will be north. Okay, and for south pole to remember, okay, since you remember anti, the other one has to be south pole, so at least remember anti. In the word anti, N is there. Okay, so these small hacks, tricks, if it will help you in exam, it will be very good. Okay, so now let us write some points about the solenoid. Okay, before we end the video. So now whatever we have just discussed, let us take down some points. In this video, I'll be discussing only about the solenoid. Okay, now let's take down some points. Number one, one side acts as north pole and the other acts as south pole. We have already discussed about this. One side of the loop in which the direction of current is clockwise will act as the south pole, and the other side, okay, in which if I view from here, the current in the loop becomes anti-clockwise. Anti means north pole. Okay, so one side of the loop south pole, the other side of the loop north pole. I hope it's clear. Next, point number two, strength of magnetic field. Strength of magnetic field, FIELD. Strength of magnetic field can be changed by. Now, the strength of the magnetic field generated or produced in a solenoid can be changed. It depends on certain factors. Let us have a look at each one of them one by one. So it depends on the first one. It depends on the increase the strength of magnetic field can be changed by, yes, increasing the amount of current. What does it mean? It means if we increase the amount of current, okay, flowing through the solenoid, the magnetic field will also increase. So for example, if current flowing in the solenoid is I in wire A, and in wire 2 the current through the loop is say 2I, then which will have, okay, in wire B it's 2I, in wire A it's I only. So who will have stronger magnetic field? Wire B will have stronger magnetic field. Okay, so wire B will have strong magnetic field. So wire B has got greater magnetic field. Remember this. Why? Because more current is passing through wire B. Okay, so remember, by increasing the amount of current, magnetic field can be changed. Lesser the current, lesser magnetic field. Stronger the current, stronger magnetic field. So next point, increasing the number of turns. Increasing the number of turns. Whose turns are we talking about? Whose turns are we talking about? We are talking about the turns. Okay, we are talking about the loops. So, for example, if we have 1, 2, 3, 4, okay, and then if we have, okay, let's make it like this. So 1, 2, 3, 4, okay, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So wire A, loop B. So who will have more magnetic field? Okay, the magnetic field of B will be bigger again. Why? Because it has got more turns. Okay, more number of turns means greater magnetic field. Okay, more magnetic field. Next, Next point, decreasing the gap between copper turns. So decreasing the gap between wire turns. Okay, so what does it mean? It means this one. So if, let's say, the gaps are this much, okay, like this, then, or let's put one more here. So 4 loops, 1 or 3 loops, and then the gaps are this big. But if we decrease the gap, by decreasing the gap we mean like this. So 1 2 3 4 5 6 7 8 9 10. See, the area taken here is this big, and here, okay, it's even smaller. So this much, so this much, that means, so I can even draw more. So in such a small, see, okay, see, check out the length of the loop is this much, and the length of the loop is this much. Same length of loop, but check out the number of, okay, turns. I'm getting more turns here, okay, I'm getting less turns here. Why? Because here the distance, okay, the gap is more, okay, the gap is more, okay, the gap is way big. See, check out the gap. Here the gaps are very less, okay, very less. So if we decrease the gap, then we produce stronger magnetic field. Next, and the last factor, the last point, nature of medium inside the core. So nature of medium inside the core. What does this mean? It means what makes up the core. Okay, nature of medium inside the core means what makes up the core. So let's come back to the solenoid here. So the core is this part. This part is called the core. My dear students, the core is from this to this part. Okay, this part is called the core. So this area, okay, now this part where my hand is moving, this part is the core. So nature of medium inside the core. So inside the core, what is present inside the core? Currently, what is present inside the core? Nothing is present inside the core. Okay, the core is empty. Okay, so by default, nothing is present inside the core. If at all something is present inside the core, it will be air. So by default, the solenoid will have air core. So just important information. By default, the core in a solenoid is, the core is air. Okay, remember this one, very important if they ask in MCQ. Okay, what is the core in a solenoid? So it will be, by default, it will be, okay, it will be air if it is a solenoid. But here I want to be very clear that the core, okay, the core can be changed. Remember this, the core can be changed. Currently in a solenoid, nothing is present inside the core, it is air only. Okay, so in a solenoid the core is empty, but we can insert things. Okay, we can insert things inside the core. Okay, we can insert things inside the core, and when we insert things inside the core, then it becomes a totally different thing, which we'll be studying in the next video, which will be an electromagnet. Okay, if the core is not empty, and if the core is filled, yes, the word is filled. So if the core is filled, so with what are we filling? We can fill the core of the solenoid with a hard iron or a soft iron. So we can fill the core of the solenoid with a hard iron or a soft iron. And if we fill the core of the solenoid, then this will give us an electromagnet. So like I said, an electromagnet is a different topic. We will be discussing this in the next video. But in today's video, which is about a solenoid, remember, there is nothing inside the core of a solenoid. The core of a solenoid is empty. If at all they ask you, then remember, okay, since nothing is there, what will be there? There will be the most air particles, isn't it? So by default, the core is air. Okay, so I hope you have understood something. Okay, I hope I've been able to clear your doubt, and I hope I've been able to put some substance into the topic of a solenoid. So in today's video, this is all, okay, which I wanted to discuss. In the next video, we'll be discussing about an electromagnet in detail. Okay, in today's video, I just wanted to talk in detail about a solenoid. So I have tried my best to explain to you in detail, okay, what a solenoid is, okay, why do we study a solenoid, and everything that's happening in a solenoid. The most important part here, which students get confused again and again, okay, is identifying which end will be north, which end will be south. So remember, okay, do not get confused. I have already told you how to determine which end is north, which end is south. So before I go, okay, I'll give one more question. So the question for today, and I want you to participate, kindly participate. So this is a current carrying loop, okay, and then plus minus, okay, let's make it like this: minus plus, minus plus, minus plus, minus plus. So like this is plus, this is minus, current is entering from here and current exits here. Let this be A, let this be B. So the question is, indicate north and south on this solenoid. Okay, so indicate the north and south in this solenoid. Is A north or is B north? So this is the question. Indicate north and south. Kindly comment the answer in the comment box. Okay, I go through all your answers, so I want you to participate, and then let me know whether you have understood or not. So this is it, my dear students. Thank you all for tuning in and learning, and I'll see you again in the next video.